Welcome to this video. Today we are going to see abrasive jet machining in unconventional machining process. Before going into the abrasive jet machining process, we are going to see what is unconventional machining process. In this process, generally unconventional machining process, the metal is removed by using some sort of tool which is harder than the workpiece and which is subjected to wear. And here tool and workpiece are in direct contact. This is the basic of conventional machining process. What are the demerits of conventional machining process? In the conventional machining process, metal is removed by chip forming, which is an expensive and difficult process. The second factor is chip produced during this process is unwanted byproduct. And the third one is removal of these chips and their disposal and recycling is a very tedious process which involves money and energy. And the next one is very large cutting force are involved in this process, so proper holding of workpiece is most important. Due to large cutting force and large amount of heat generated between tool and workpiece, undesirable deformation and residual stresses are developed in the workpiece. These are all the demerits of conventional machining process. What is unconventional machining process? Or it is basically non-traditional machining process or unconventional machining process and unconventional forming process. This is what unconventional machining process is about. We need to know what is unconventional machining process. In this process, there is no direct physical contact between tool and the workpiece. Therefore, the tool material need not to be harder than the workpiece as we have seen in the conventional machining process. Traditional or conventional machining process is broadly classified into cutting and mechanical abrasion. In cutting, circular shape and various shape. In mechanical abrasion, bonded abrasive and loose abrasive. In circular shapes, turning, boring, drilling operation takes place. In various shapes, milling, planing, shaping, broaching, filing, gear forming, gear generation takes place. In bonded abrasive, grinding, honing takes place. In loose abrasives, polishing, buffing takes place. These are all the basic traditional or conventional machining process we come through in day-to-day life. What is the need of unconventional machining? What is the need of the hour for unconventional machining is? It has a great improved thermal, mechanical and chemical property of modern materials. Ceramics and composites can be machined. In addition to advanced materials, more complex shapes, low rigidity structure, micro machined components can be also done or can be machined using this process. To meet this demand, a new process are developed. Here, in this unconventional machining process are widely used in aircraft, automobiles, tool, die and mold making industries. These are all the basic need for unconventional machining process. Basically, the unconventional machining process is classified or non-traditional machining process is classified into four categories. One is mechanical, second one is thermal, third one is chemical and electrochemical, and the final one is electrical process. In this, today we are going to discuss about abrasive jet machining, which comes under mechanical machining process. Abrasive jet machining. Before going into the abrasive jet machining, the abrasive jet machining arrangement or setup will look like this. Basically, the abrasive particle is made to fall on the workpiece, and with the help of the abrasive jet particles or abrasive particles, we are removing the material from the workpiece without any contact of the workpiece with tool. And we will see what are all the setup which is available or arrangement of the abrasive jet machining one by one. First, we are going to supply a air or a gas for this process. Second, a filter is being used so that the gas or the air which we are sending to the process is filtered. And the third one, we have a compressor. It compresses the air which are supplying in. Third one, we have a pressure gauge. What is the pressure we need for the operation? We will arrange in this pressure gauge or set in this pressure gauge. Then we have a air regulator which regulates the air which is been flowing inward, and we have a mixing chamber where the air, the pressurized or the pressurized air is being mixed in this chamber with the hopper which is mixing the or which is giving the abrasive particles. The abrasive particles and the air is mixed in this chamber, so it is called mixing chamber. And then the air is being made to flow through the hose, and where it has a pressure gauge where we can adjust the pressure according to the need of our operation. Then we have a control valve for jet flow, for the flow of this pressurized and the air which is mixed with abrasive is being passed through this hose through a jet valve. Then it is being made to pass through the nozzle where it is been its velocity or its speed is increased, and the abrasive particle is being made to fall on the workpiece, so that with the help of the abrasive particles which is falling on the workpiece, our required shape is being obtained. In this process, the material is removed from the workpiece. It is material removing process like the conventional machining process. And the main difference in this process is we are not in contact with the workpiece. Tool is not in contact with the workpiece. As you can see in the diagram, just the abrasive particle is falling on the workpiece. By the falling of the workpiece with a high velocity, the material is removed from the workpiece. This is how this abrasive jet machining works. We will see the constructional details. The gas which is used in this process is nitrogen, carbon dioxide and compressed air. Abrasive particles, mostly what we use in this process is aluminum oxide, glass powder, specially prepared sodium bicarbonate and etc. Nozzle what we use here is tungsten carbide is the nozzle we generally use here, or ceramics we will use here. And these are all the abrasive particles we will use: glass beads, aluminum oxide, silicon carbide or dolomite. What is the nozzle life? If we use tungsten, the nozzle life will be 12 to 20 hours. Synthetic sapphire we use average of 300 hours is our nozzle life. What is the shape and size where we can cut? The cutting shape and size is being given or by the mechanism is given by cam mechanism or phanetography mechanism. By this two mechanism, the size and shape of cut is controlled by a movement adjusting mechanism given to the workpiece or tool is by this two type of mechanism we are using in this machining process to cut the workpiece. Generally we use 2 kg per centimeter square to 8 kg per centimeter square as the air pressure in this process. What are the advantages? We can cut all kind of material, no heat produced in this process, very thin and brittle material can also be machined, low initial investment, good surface finish. These are all the various advantages in this process. Disadvantage: low MRR rate, that is low material removal rate. Soft materials cannot be machined, machining accuracy is poor, nozzle wear rate is high. So these are all the required dust collecting system. These are all the main disadvantage of this system. What is the application of this system is? This is mainly used for hard and brittle materials like quartz, ceramics, glass, sapphire. Fine drilling and micro welding can be done. Machining of semiconductors can be done. Cleaning and polishing of polyesters, plastics, nylon and Teflon components can be done. Surface etching and surface preparation can be also done. These are all the main application of this process. By this you can clearly understand the function and working and construction of abrasive jet machining, so that we can see some other application in next video. Thank you.